Good afternoon, and good evening, and welcome to this webinar on how to ace number properties. As I said earlier, the focus of this webinar is going to be on just one topic, which is the topic of remainders. And in this topic, we're going to go from the easiest questions, from solving the easiest questions to solving the most challenging questions. And then we're going to make this transition um, over about 15 questions. So it's going to be a fairly fast-paced session because we'll be solving a question almost every 4 minutes or so, 4 to 5 minutes or so. Now, to just set some context for the session, I want to understand where you currently stand, and so I have a few poll questions. One is, what's your current quant score out of 60? And the next one that I'm going to put in over here is, what's the score that you're targeting for? Actually, wrong poll. What's your target quant score out of 60? So I'd like to get that as well. All right, I need a few more responses. The first question was, what's your current quant score? I only have about 40 responses to that one. I have about 115 odd students in this webinar, so it'd be great if I can get a few more responses. And then the second one is, what's your target quant score out of 60? On the target, I actually have more responses, about 60 responses over there. And on the target, what you really see is about 80% of the classes either at a 50 or a 51. On the current, the biggest group is those who are currently at a score of lower than 40. Okay, with that, so many of you need to improve your quant ability by quite a margin. So let's see how we can help you get there. And just to understand the kind of time you guys have as a group, what we see is about 40% of you haven't taken a date as of yet. Another 30% are in that 46 to 75 bracket. So that counts for about 70% of the class, give or take. And then the remaining 30% are in that 0 to 45 days bracket. Now, to do well in the session, you do need a certain foundation in quant. And again, I use the word quant and not math because GMAT quant is not as much about math as it is about inculcating some good habits, or what we call as a certain set of process skills, which we're going to talk about. So to make sure that you have that background in quant, we did send a few video lessons your way. These video lessons were in primes because prime sets the foundation for divisibility as well as for remainders. If you've not watched these video lessons, just log into the e-GMAT account post this webinar, and you'd go right into our number properties module over there, and you can start watching these video lessons. Also, we have some upcoming free webinars. We have a free webinar on reading comprehension. For those of you who struggle with RC, for those of you who think, hey, the only way to ace GMAT RC is by reading lots and lots of books and novels and The Economist and so on and so forth, I'd like you guys to attend this webinar. In this webinar, we demonstrate how even a non-voracious reader can actually ace GMAT RC if he or she focuses on a few key reading strategies and improves his or her comprehension by doing so. And then tomorrow we have, a week from now, we have a quant workshop. Think of this workshop as a personalized quant mock in which we not only tell you what your current score is, but also tell you why is it that you're struggling in certain areas. So which are the areas that you're struggling in? Why are you struggling? What's holding you back? So think of it like a proctored mock test, but with a lot of personalization. So that's a week from now on 7th of June. And then on Monday, which is tomorrow, in about 25 hours, we have face-to-face with a Kellogg Ed Metapurva, who's going to talk about how did he position his candidacy at Kellogg. And so again, these are what we call as brutally honest sessions, where we ask pretty much any question is fair game, and the response that we expect is supposed to be brutally honest. More so because it's about something that we want to educate. The whole reason why we do these sessions is to make sure that that you get to know how people who do well on the GMAT go about getting into their dream B schools. What steps do they take? What considerations do they have when they make a choice? and so on and so forth. So if you've not registered for this one, you can click on register now and get to it. With that, let's go right into the webinar pane. And let me just clean up the webinar pane a bit. So as I said, this is going to be a fairly fast-paced session. So let's kind of get started with the session right away. Oh no, start with this slide over here. So even though we're going to focus just on remainders in this, one of the takeaways that I want you to have from this session is when it comes to acing GMAT quant, it's not about doing complex math. It is about having the right basics. But on top of that, which I think most of you have the right basics, that's kind of what my experience has been. But on top of it, you need what we call a certain key process skills, and those process skills amount to having a structured approach to solving questions. The other takeaway that I want you to have is that getting a Q50 or a Q51 on GMAT quant is not about doing the math. It is about understanding how to approach the problem. In fact, if you understand how to approach the problem, 9 out of 10 times you don't even need to do the math the way you traditionally used to doing the math. And again, once you understand that, taking the GMAT, whether you're taking the in-center GMAT or the online GMAT using the whiteboard, becomes fairly easy. And that's something that we've been seeing. I mean, off late, we've been getting many scores of people getting to a Q50, a Q51 on the online whiteboard, whereas prior to that in the in-center math, they were scoring a lot less. So how would the session progress? So we're going to start with a few 700 level questions. These 700 level questions are going to be what we call as our holy grail. This is where we want to get to. And we'll only solve these questions. We will not discuss them. And because you would know this is what we are kind of building up to. Then we'll start with a basic warm-up. We'll start with the very easiest, the easiest questions that you can get in remainders. Then we're going to solve a few problem-solving questions, which are going to be 650 to 700 level. Then a few another a set of problem-solving questions, which are going to be 700 level. And then we're going to come back to the same DS questions that we started with. And again, the goal really is that throughout this session, we're going to build our ability up to these 700 level questions over there. So essentially, the 700 level questions that we want to get to are we call them question numbers 8 to 10 because that's what they would be. The warm-up questions, we'll do about 5 questions over here, and these are, think of them as 0.1 to 0.5. We don't count these questions, but as you go into the problem-solving questions, you can see the counter resets over there, and then we end up with questions 8 to 10. All right. So that's how we're going to go about doing it. So if you don't have a pen and paper or a whiteboard ready, make sure you have one ready, and because we're going to start solving some fairly difficult questions, 700 level data sufficiency questions, and so make sure you have a pen and paper ready. Make sure you have a bottle of water ready with you. Now, how we go about solving these questions is essentially, I don't like to time you guys. So what I do is I give you this option which says still solving. So if you click on still solving, I have about 175 students in the webinar right now. If 100 of you tell me still solving, and then later on, once I show the question to you, you choose another answer choice. I know you've done solving, and that's when I call time. So that way, you as a group time yourself. I don't time you guys. All right, let's get to still solving. Let's get 100 people to select still solving. I only have about 48 people who selected still solving. So got a few more folks to select still solving before I show the question. That way, I'm not going to rush through the question, and you're going to get ample time to solve the question. 85, 86, 87. Let's get to 90. All right, so here is your first question. All right, 80% of you are done, guys. Let's get the answer in. 5, 4, 3, 2, and 1. All right, let me end the poll. I'm going to broadcast the results. Choice C is the most popular choice. Choice A is really popular as well, but then now you can really see the distribution across other choices. Now, one of the things that I'd like to tell you guys is that, if you're here in this webinar, participate. Why? Because that's the way you're going to get the most out of this webinar. And so this is what I call as a very low risk environment. So you're not here to get all the questions right. You're here to learn. And since you're here to learn, the best way to learn is to get feedback. The only way you get feedback is if you participate. So I'd like to see a few more responses next time, especially those of you who are in that still solving bucket. Take a stand overall. Okay, so with that, we're going to solve the next question. For those of you who've just joined us, what I'd like to remind is they're solving 3 questions. These 3 questions are difficult questions. They are our holy grail. This is where we want to get to. So let's get to, so before we get to the next question, let's get to still solving. I want to get to 90 people saying still solving before I show the next question. And again, if any of you face audio issues during this webinar, just try to log in again, and then the issues will usually sort out by themselves. Am I going to walk you through these? Yes, I will. So this is what we want to build towards. This is our holy grail. So I'm going to just show this is what we want to get to. And towards the end of the webinar, we're going to discuss these questions. In fact, you guys are going to solve these questions again because you'd be able to solve these questions by the end of the webinar. Okay, I have 87 people who've said something. I want to get 3 more people. I want to get 90 people to say still solving. All right, I have 91. I'm going to remove broadcast results. Here is my next question. Good. All right, guys, about 80% of you are done. I'm going to give you another 50. All right, 5, 4, 3, 2, and 1. I'm going to end the poll and broadcast the results. So again, C choice A is quite popular, C is popular, D as well as E. I mean, pretty much every choice is popular. You guys are warming up to this now. That's great. Um, so we're going to, just to really tell you, we're doing a marathon. We're not going to discuss these questions yet, but we're going to build our abilities towards these questions. These questions are our holy grail. And so we're going to discuss these 3 questions towards the end. So I want you to attempt these questions now so you can really see, if they seem difficult, why do they seem difficult? So that towards the end, you can really see how things become easy. So let's get to uh, about 80 people, 90 people saying still solving. I have 60, 62, 65, 70. Wow, I love the pace. 80 and close to 90 people saying still solving. Here's the next question. Here's question number 10. Good. All right, almost 80% of you are done. Let's get this through. I'm gonna give you guys another 15 seconds. All right, 3, 2, and 1. Let's get those responses in, and then let's end the poll. End the poll. Here are the results. As you can see, choice C was really popular, and then after that, choice A was the next most popular choice. But a significant number of you also chose choices B and C. Now, just we have a bunch of people who've joined recently. Just to really tell you what we're doing is we solve 3 data sufficiency questions. These 3 questions are all holy grail. This is what we're going to build up to. So we are not going to solve these questions yet, but this is what you can expect to be able to get to once we are through with the session. So we're going to discuss these questions towards the end. Now, with that, let's now this is our assessment mode that's done. Now let's go into the capability building mode. And one of the things that I want to do during this session is is that I want to actually build some good habits. So one of the first so the first thing that we're going to kind of vow to do during this session is build this one habit, which is I'm not going to do the hard math. So when it comes to solving GMAT quant means not doing the hard math. Because you can solve some questions, and especially the easier ones, by doing the hard math, but that's not what we want to do. Why? Because if you end up doing that, you don't inculcate those good habits. If you don't inculcate those good habits, you won't be able to solve those 700 level questions, because those are going to be incredibly difficult if you try and solve them by doing the hard math. So we're going to start building these good habits from the easiest questions. Why? Because it may be a bit more painful when it comes to the easiest questions, but once you start building those good habits, you're going to find life starts to become very easy once those habits become second nature. Okay. Now with that, we're going to start solving some really easy questions over here. And while I do that, let me just introduce my colleagues to you. Supporting me in this webinar, we have Aarti, who's a CR expert, who's a physicist by background, and she's going to make sure your questions get answered. We also have Sandeep, who's a GMAT strategy expert, and he's also going to support us during this webinar. Okay, so now we're going to actually go to a completely different end of the spectrum. We solved some really challenging data sufficiency questions. We didn't discuss them. Now we're going to get to solve some really easy questions, because this is what we call as our warm-up section. Okay, so so we're going to solve some very basic questions on divisibility and remainders, and then the idea really is we kind of understand what's the conceptual buildup of this group, and while over here we will provide solutions, because we want you to learn that the extent of detail in the solution is going to be these solutions is going to be very limited. Why? Because we expect you to know these questions. But as we go from here to 600 level questions, the solution will be more detailed, uh, and answer way more of your questions over there. All right. So with that, let's get a few more people to still solving before I show you the first question. Let's get about 70 people to still solving, since these are easy questions. I'm not going to put a really high bar over there. 3, 2, and 1. Wow, we have 100 people, almost 100 people saying still solving. Here is the first question. About 80% of you are done. Let's get those answers in. 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. 70% of you chose choice B. Choice B is the correct answer. And again, you can really see there are only 3 choices here. This is not a GMAT-like question. Again, the goal really is to build skills, not really to have you solve GMAT-like questions. That stage will come in about 15 minutes. So what's given to us? These are 3-digit numbers whose digits are consecutive numbers in increasing order. Select which of these statements apply. Okay. So what's the divisibility rule of 3? That sum of digits should be divisible or must be divisible by 3. What this means is we can express z as x plus 1, and x plus 2. So that's kind of where 3 digits, the first digit is x, the second is x plus 1, the third is x plus 2. So what's the sum of digits? You add them, and let's just remove this annotation. Okay. And you get 3x plus 3. Then you get 3 times x plus 1. And in the end, you get the same thing. So this is what if x is negative, you're gonna get the same thing either way. It's 3 numbers. It's always going to be a, b, and c, where x plus 1, and x plus 2. So and again, one of the things when it comes to remainders on the GMAT is we're talking about positive numbers, not negative numbers. Okay, so that's something which is there. That's something. It's in the same way that on the GMAT you always deal with real numbers. You don't have complex numbers. So square of a number on the GMAT is always positive, not negative. So what you really see is it's 3 times x plus 1, and it's 3 times a number, which means it's always divisible by 3. So your correct answer is choice B. Now, very basic question. We're going to take this forward in the next one. Let's get to still solving. Let's get about 80 people to stay still solving, and then I'm going to show the next question. That is great. Almost 80% are done, guys. I'm going to give you another 15 seconds. All right, 3, 2, and 1. Let me end the poll, broadcast the results, and you can clearly see we have a split jury between choices A and C. So let's kind of go about doing this. What's given to us is Z is a 4-digit number, and again, whose digits are consecutive numbers. Select which one of these statements apply. So what's the divisibility test for 4? Let's get in a short answer poll. Hold on. Yeah. What's the divisibility test for 4, guys? What is the divisible? Yeah, the last 2 digits must be divisible by 4. That's great. You guys know that. So we say, hey, the last 2 digits should be divisible by 4, or they must be divisible by 4. So let's kind of start taking some cases. And here we are bringing in a core skill or a process skill of considering all cases. So we can say, hey, what if z is odd? And if, for example, z could be 2, 3, 4, 5. Again, an odd number is not divisible by 4. So that's something where z is not divisible by 4. But z could also be even. And where the last two digits are divisible by 4. So an example would be where the last two digits are 5 and 6. So 3, 4, 5, 6, 56 divisible by 4. So this is where z is divisible by 4. Also, there could be a scenario where z is not divisible by 4. For example, if it's 1, 2, 3, 4. So, the correct answer is there is a possibility that z is divisible by 4. There's a possibility that z may not be divisible by 4. So the correct answer is choice A, which is z may be divisible by 4. So both possibilities exist over here. Okay. Now let's go to the third one over here. And this one will have 4 answer choices. So again, I have a new poll for you guys over here. So select still solving. Okay, we've gotten more than 80. Here is the third warm-up question. All right, about 80% of you are done. Let's get those answers in. 5, 4, 3, 2, and 1. So the question asks, let me end the poll, broadcast the results. 81% of you got it right. Most of you did. So the question says, what's the closest number closest to this number that is a multiple of 8? So we say, okay, we go by the same thing. We say, hey, what's the divisibility rule for 8? It is that the last 3 digits should be divisible by 8. And we look at this and say, hey, it's around that 890 to 900-ish over here. So we look at the last 2 digits and say, hey, which one of these is divisible by 8? And we look at 897, and essentially 897 by 8 gives us a remainder of 1, which means the number closest to this that's divisible by 8 is 896, and which is where choice C comes in, and about 81% of you got to that over here. Now we're going to start solving slightly different questions. Again, still easy questions over here. So here is the next question. All right, 85% of you are done. Let's get those answers. 3, 2, and 1. Now, I'm going to end the poll, broadcast the results. A good chunk of you got this right, but tell me how many of you did the math uh, 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 to get to the correct answer. Select yes if you actually did the math. Select no if you did not do the math. Because again, remember, we said the purpose of this session is to not do the math, to inculcate good habits, because only when you inculcate good habits, that's when you get to that ability where you can solve difficult questions. All right. So about 35% of you did the math, and let's kind of really see how you should have gone about solving this question, because you got the answer right. But again, we want to make sure we solve it using a method that's a scalable method. So the concept that we always use when it comes to remainder is dividend is equal to divisor times quotient plus remainder. It's the most basic equation when it comes to remainder. So what's given to us? What's given to us is that n leaves a remainder of 3 when divided by 2 or 4. So essentially what this means is that, so again, first let's kind of really see what do we have to figure out. We have to figure out what's the remainder when n is divided by 4. So what it really means is we have to express n as 4p plus r. Okay, that's our goal. If you can express n as 4p plus r, then r is our remainder. And remember, r has to be a greater than or equal to 0, and b, it has to be less than your divisor. Those are the two constraints that R has to satisfy. So we really say, okay, what's given to us? N is equal to 204q plus 3. All right, and then we visualize. We say, hey, this is what's given to us over here, and this is what we need to get to. So that's the visualization that we do. So let's kind of go about doing this now. 204q can be written as 4 times p. So what it really means is we can really say, hey, 204q is 4 times 51q, and which means you can write n as 4 times 51q plus 3, which means that this quantity is completely divisible by 4, which means you get 3 as the remainder, which is where you guessed choice D. Now again, as I said, you could have done the math, but that's not how we want to go about doing it. We want to actually do this in this particular manner in which we don't have to do the math. Okay. We're going to solve one more question using the same concept. We're going to this time apply the remainder equation. But before that, let's get to still solving. Can you solve this by plugging in for n? You can, but that's not how I would want you to do this, because remember, it's about inculcating good habits. And plugging in may work for easier questions. It's not going to work as questions get more challenging. Okay. All right. We have 87 people, or about 90 people who've chosen still solving. Let's get to our last question before this particular round, before we go on to more challenging questions. All right, 80% of you are done. Let's get those answers in. 3, 2, and 1. Let's end the poll. And I'm going to broadcast the results. And you can really see it's either choice A or choice D is where people have gravitated towards. The correct answer is choice A. Again, we're going to do a very, very simple, we're going to have actually an identical approach to what we had for the last question. We're going to use the same concept. Dividend is divisor times quotient plus remainder. That's something you're going to actually get sick of me talking about this equation, because I'm going to talk about this equation till each one of you uses it. So bear with me and start using it, because otherwise you're going to start feeling sick. So what do we have to do? We've got to figure out the remainder when n is divided by 5, which means we have to express n as 5p plus r. Remember, the remainder always has to be less than the divisor, and it always has to be greater than or equal to 0. Okay, so what's the divisor here? The divisor here is 5, so remainder always has to be 5, less than 5. So for those of you who chose 6, that's you kind of miss a very big thing. A remainder can never be greater than the divisor. Now, what's given to us? What's given to us is that n leaves a remainder 6 when divided by 205, which means we can express n as 205 times the quotient plus 6. All right. And then we do the same visualization skill. We really say, hey, we've got to express n as 5p plus r. What's given to me is n as 205q plus 6. Let's go about doing this. We can really say, hey, 205q can be written as 5 times p. Why? Because 205 divides 5 properly. So, which means 205q, which becomes 5 times 41 times q. And then you could really say, hey, the remainder, which means that this is something that's divisible by 6, so the remainder, divisible by 5, I'm sorry. So my remainder is this number 6 over here. And if you did till this point and you stopped here, you kind of missed a critical step, which is the remainder has to be less than 5. Okay. So then you really say, okay, what about this? What about this constraint? This is what we call as applying constraint. So we say, hey, 6 is 5 times 1 plus 1. So 5 times 1 divides 5 evenly. So the remainder is 1. Okay, that's how you get to the answer. That's the approach that I want you to take. Because yes, you could have taken an example. You could have really said, hey, if n leaves a remainder 6 when divided by 205, an example of n could be 211, and then let me divide 211 by 5, you get to the answer as 1. You could do this for this question, but it's not a scalable approach. That's not an approach that I want you to take. Okay. So again, overall feedback. Where is it that where we actually did some very basic. We started the session with solving 3 of the most challenging data sufficiency questions. Those questions were our holy grail. That's what we're going to build up to. And to start building up to that, we solve some really simple questions. These are 500 level questions. The goal of us solving these questions is to make sure that you get 200% clarity in concepts. If you scored less than 100%, if you have less than a perfect score, then make sure you revise the recommended concepts, because as we get to real GMAT questions, the extent of application becomes a lot more advanced overall, and so this clarity is required. Hopefully, you are better prepared for the next set of questions than you were a few minutes ago. Now, with that, we're going to start solving some 600 level questions. And again, we're going to start with our question number 1. Once again, I want you guys to select still solving. And we're going to start with very easy 600 level questions. So even though the next slide will say 650, the first 2 questions would truly be 600 level, and then they're going to go to 650 to 700 level questions overall. Okay, so here is the first. All right, 80% of you are done. Let's get those answers in. 5, 4, 3, 2, and 1. Let me end the poll and let's broadcast the results. So about 60% of you got it right. But again, I want to make sure that you do it by not doing the math and by do it by really taking numbers. And yes, we'll take such questions, Shubham, where the example approach will not work. We're building up to that. Okay, so what's given to us is that m is a positive integer and m by 30 is 8.2. What's the remainder when m is divided by 15 is what we need to figure out. So let's start with this. Again, we start with the remainder equation where dividend is divisor times quotient plus remainder. And we say, what do we have to figure out? We have to express m as 15p plus r, where r is greater than 0 and less than 15, greater than or equal to 0 and less than 15. Okay. What's given to us? What's given to us is that m is equal to 30 times 8.2, which means you split 8.2 as 8 plus 0.2. So you say m is 30 times 8 plus 30 times 0.2. Okay, that's what we call as visualization, or you're putting in the distributive property of addition. And again, you visualize this and you really say, hey, this becomes, the first part becomes over here 15 times 2 times 8. Why? Because 30 can be expressed as 15 times 2 and 30 into 0.2 is 6. So you get the first part over here. This part is completely divisible by 15, which means that my remainder is 6. Over here. And which is kind of how I want you to do it. Not by doing the math, not by really saying, hey, m is 246, but by just simply using the remainder equation. How many of you use the remainder equation? Okay, only about half of you did that. I want more and more of you to do that because that's the approach that we want you to take going forward. So let's go into still solving again. And before we go and do the next question, 3, 2, and 1. And move broadcast results. Here is the next question. Very similar question, guys. Let's get to the answer. All right, let's get to the answers. We pretty much are done with this. Let me end the poll, broadcast the results, And pretty much all of you got to the correct answer. 81% of you got to the correct answer. Again, what's given to us? We're given to us as m is 30p plus r, where remainder has to be less than 30. What we are supposed to do is we have to figure out, or what's actually given to us is m is 15 times 8.2, and what we have to express is m as 30p plus r. So let's go about doing this. Let's visualize this, and we split m as 15 times 8 plus 15 times 0.2. Again, as we visualize this, we can really see that this number 15 times 8 is divisible by 30. Why? Because you can express 8 as 2 times 4, and which means it's a multiple of 30. So that's 15 times 2 is 30, 30 times 4, that's divisible, and then 15 times 0.2 is 3. So when you compare this to this equation, you can really say that the remainder is 3 over here. Again, I can really see that some of you are doing it in the right way. Others are still doing the math over there. So I want to make sure that we don't do it, because as we go forward, you're going to find that that in the following questions, doing the math starts to become challenging. Okay. So is it possible for the remainder to be decimal? No. No, Muskan. So let's go to the next question. This is the third question in this. It's going to be the last of the easy questions over here. Let's go to broadcast results. Still solving, I'm sorry. And then as we do that, we're going to start making questions a bit more challenging. All right. Here is the next question. All right, group, 80% of you are done. Let's get to it. 3, 2, and 1. We end the poll, broadcast the results, and again, 67% of you got it right. We have a significant number of you who actually chose choice B, which is wrong. So again, same equation. We're going to continue to harp upon this equation till the end of this. The challenging questions that you saw, that we solved using this equation as well. So what's the equation? My dividend is divisor times quotient plus remainder. And what the question asks me is, what's the remainder when m is divided by 30? And remember, what it means is that the remainder has to be greater than or equal to 0 and less than 30. What's given is that m is equal to 15 times 9.2. When we say m by 15 is 9.2, m is 15 times 9.2, which means I can visualize this and I can really say, hey, m is 15 times 9 plus 15 times 0.2. Now I ask myself, I have to express m as this form over here. and I know 15 times 9 is not, divisible by 30. So let's kind of split it even more. Let's visualize this even more. So where I express 9 as 8 plus 1, so I do this as 15 times 8 plus 1 plus 3, which means I get 15 times 8 plus 15 times 1 plus 3, which means I get this number, which is divisible by 30, and these two numbers that are not divisible by 30, and I add them up and I get 15 times 30 times 4 plus 18, which means 18 becomes my remainder. So that's kind of where I get to. Okay, and thus my remainder is 18. So again, this was the last of the easy questions over here. And my correct answer is choice E. And again, as an overview of question numbers 1, 2, 3, very, very basic concepts with regards to the basic remainder equation. We primarily focus on the skill of visualization. That's a very foundational skill. Why did we focus on this skill and on this equation? Because we're going to build upon the skill as we get to more challenging questions overall. In the first question, we pretty simply were given that m is 30 times 8.2. We had to figure out what's going to be the remainder when m is divided by 15. And the second one, it was just opposite. We were given a m as 15 times 8.2. We had to find a remainder when m was divided by 30. We used the exact same process. The only thing which was there was we actually split 8 over here into 4 times 2, and which means we were able to express it this way. The third question, which is the last question that we solved, we were given m as 15 times 9.2. Again, we split 9 as 8 plus 1, and then we got the remainder as 18 over here. Again, same equation, just a bit more sophisticated visualization is what we achieved as we went from question number 1 to question number 3. Now, we're going to go to solving slightly more challenging questions. But before that, I'd like to clarify, a couple of you have asked about the online GMAT. The online GMAT is a GMAT that you take at home. The status of that is you can now book the online GMAT till the 15th. So that's something that's possible over here. And again, the in-center GMAT, I don't know when it would be, when we'll have the ability to take the in-center GMAT, but we are the only company that offers an identical whiteboard solution that's kind of very similar to what you have on the online GMAT, where we have a floating whiteboard within the question stem. And I think the whiteboard is in my opinion, a great asset, and the results that we've been getting, they've been very, very positive. Here is an example where someone who struggled to score more than 670 in the in-center GMAT actually scored a 730 on the online GMAT. Will the attempt be counted? Yes. I mean, when you say it won't be counted towards your in-center attempts, but you can only take the online GMAT once. That's something which is there. The online GMAT, from what we've been told, the dates are available till July 15th. If you face issues, let us know. We will reach out to the GMAT because I have them on record in my communications, where they say if you face issues, if any of your students faces issues while booking the test date beyond June 15th, so between June and July 15th, let us know. Okay, with that, if you have other questions, write to me. I don't want to derail this session. I just wanted to make sure that I answer this one question, that you can take the test till July 15th. Okay. And again, for those of you who want to know what are the conditions for online GMAT, I can also send you a video. You can really see that. We've created a video for our students where you can, which this video pretty much answers every question that you have. You can watch this video and all right, with that, let's kind of start solving more challenging questions over here. And I want to make sure, again, that you start to use this equation if you've not started to use this now, because this is an equation you're going to use again and again going forward. And in the next set of slides, we're going to build upon this understanding with regards to addition and multiplication of numbers and the remainders that we get when we do that. So the first thing that we're going to really talk about is okay, addition of numbers and the remainders in context of it. So if I were to tell you, hey, what's the remainder when 31 plus 43 is divided by 7? The answer is 4. And there are two approaches you could have taken. One is you could have just added the two numbers. You get 74. You divide 74 by 7 and you get the answer as 4. The other one is the sequence 2, which is our preferred sequences. You do 31 by 7, you get the remainder as 3. Do 43 by 7, you get the remainder as 1. And then you add the two remainders and you really say, hey, when I add the two remainders, the resultant sum is still less than 7. So it satisfies my constraint in the remainder equation. So 4 is the remainder. And that's the preferred approach that I would have. Now, in this case, it may seem either one looks simple enough, but as numbers get more challenging, this would be an easier approach. Now, let's talk about multiplication of numbers. Okay, so the question is, what's the same numbers? What's the remainder when this product is divided by 7? And there are two ways again of doing it. One is you multiply both the numbers, you get 1333, and you do 1333 by 7, and you get the answer as 3. It's not the preferred approach. It starts to become onerous over there. You can really see the math becomes onerous. That's not what we want to do. The second is we find the remainder for each individual number and you multiply both of them. You say, so 31 by 7 gives us 3, 43 by 7 gives us 1. You multiply 3 times 1 and you get 3 over here. All right, so that's the approach that we want you to take over there. Why? Because you can see it's a lot more simple. Now let's understand why these approaches work. Why is it that you can add the remainders or you can multiply the remainders of individual numbers when you're adding or multiplying those numbers? So again, the key to this is this remainder equation, which is dividend is divisor times quotient plus remainder. So let's talk about adding two numbers. Okay, so essentially, when you think about 31, we can express 31 as 7 times 4 plus 3. When you think about 43, we can express 43 as 7 times 6 plus 1. So when you do 31 plus 43, what you're really doing is you're adding 7 times 4 plus 3 and 7 times 6 plus 1. So you open the brackets up, you write this equation again, and you get 7 times 4 plus 6 plus 3 plus 1, which is sum of individual remainders, and hence you get the remainder as sum of individual remainders, which is 4. So thus, you can really say we can simply add the remainders in this case. Now, the same process applies to multiplying remainders as well, where again, we can express 31 as 7 times 4 plus 3 and 43 as 7 times 6 plus 1. When you multiply these two, you're essentially multiplying this with this. And again, you expand and you simplify the bracket. Again, remember, we get the process skill of simplification. So as you simplify it, you get the first terms of both. Then you get essentially the second term of the first multiplied by the first term of second. So 3 times 7 times 6, then 7 times 4 times 1 over here. And then you get 3 times 1, which is this term multiplied by this term over here. This is just simply opening the bracket. And when you look at this, and you can really say, hey, this number is divisible by 7, so the remainder is 0. This number is divisible by 7, remainder is 0. This number is divisible by 7, so the remainder is 0. So the net remainder that I get over here is the product of two remainders, which is this, which is what I get to. Again, if you want to do it more elegantly, that's where you get to. And then this is your 7p plus r form, where r is the product of two remainders. Okay. Or in other words, if you want to simply remember this, the product of, when it comes to product of two numbers, it simply, the remainder for that is the product of their individual remainders over here. Is that clear why the sum and product property works? All right, it all stems from this basic remainder equation that we have. Now let's apply this equation to solve questions. All right, click still solving. And all right, that is great. Let me remove broadcast results. I'm going to actually move forward. Here is the question that I want. All right, about 80% of you are done. Let's get to the results. 3, 2, and 1. Let me end the poll. Let's broadcast the results. So, how do you go about doing this? You really say, hey, I can write this expression as product of three numbers, which is 25 times 38, 25 times 38, 25 times 38. So by the distributive property that we just learned, we can really figure out the remainder for each term, and then all the remainders can be multiplied. So let's kind of get to this. So we do 25 by 3, the remainder of that, 38 by 3, the remainder of that, and then we kind of, whatever we get as a product of these, we can cube this up. So we get 25 by 3, the remainder is 1. 38 by 3, the remainder is 2. So 2 cube is 8. Okay, 2 cubed is 8, which means the remainder, but the remainder has to have this constraint that it has to be less than 3. Why? Because it has to, the remainder always has to be less than the divisor. So we express 8 as 3 times 2 plus 2, and we get the remainder as 2. How many of you did this using this method? All right. That is wonderful. That's really, really good. I'm really glad to see that many of you did it using this method over here. Okay. Now, this is great. We're going to now get to a concept called negative remainders, which is where we can solve this question using another method called negative remainders. But overall, when you think about it, hold on, let me hide this over here. Just 1 second, guys. It's 1 second. It seems my system's kind of frozen for some reason. So by using the addition and multiplication property, you can simplify calculations quite extensively. What are those properties? Addition of numbers. The remainder of a sum of two numbers is the sum of their remainders. The remainder of product of two numbers is the product of the remainders. Again, the constraint needs to be that the remainder has to be less than the divisor. And again, you extend this property to really say when you have a power, you can actually take the power out and do the remainder and then do the power of the remainder. All right. So this is a simplification process scale. Now we're going to get to the concept what we call as negative remainders. And negative remainders is a very similar concept. It stems from again the same equation, the remainder equation, where dividend is divisor times quotient plus remainder. And so where again the remainder has to be greater than or equal to 0, and it has to be less than the divisor. That constraint always is there. Okay. So now let's kind of figure out let's look at this and say if you want to find the remainder of 5 by 2, you can really say you can write 5 as 2 times 2 plus 1 and you get 1 as the remainder. Similarly, if you want to do 8 by 3, you get the remainder as 2. How? By writing 8 as 3 times 2 plus 2. But what if you want to do it in a slightly different way? Why? Because there are certain scenarios in which it's probably is beneficial to express something as not x plus y, but x minus y over here. So what if we actually write 5 as 6 minus 1, or 2 times 3 minus 1, and 8 as 3 times 3 minus 1. So in each of these cases, what we get is the remainder that we get is a negative remainder. Why? Because here we get the remainder as minus 1, and here we also get the remainder as minus 1. And as we can really see that a remainder, the constraint is that a remainder cannot be negative. So let's see how we can process these negative remainders. So let's apply these constraints and try and process these negative remainders. So what we do is we actually convert these negative remainders into a positive remainder. And how we go about doing that is by adding and subtracting the divisor. So we say 5 is 2 times 3 minus 1, which is what we had, and we add a plus 2 and we subtract a minus 2 from 5. So essentially what we really say is 5 is 2 times 3 minus 2. So we take this minus 2 which was over here. Sorry, we take this minus 2 over here, this minus 2, and we bring it right next to 2 times 3 over here. Okay, and then we combine minus 1 and plus 2 over here. So as we do that, we get 5 is 2 times 3 minus 1, and then you get minus 1 plus 2, which is your remainders, and essentially which is the same as 5 is 2 times 2 plus 1. So that's how you convert a negative remainder to a positive remainder. Let's do the same thing with 8, where we add and subtract the divisor. Here you can really see we've added 0. Why? Because we've added plus 3 and subtracted 3 from it. Again, we rearrange the terms and you really get to 3 times 3 minus 1 and then minus 1 plus 3. What is minus 1 plus 3 plus 2, which was our remainder. So essentially the key thing that you have to remember is that your negative remainder, and you're going to see this come up on the top, your positive remainder is negative remainder plus the divisor. So if you want to express something as a negative remainder, if you want to get the actual remainder, you just add the divisor to it, and that is your positive remainder overall. Okay, let's apply this concept to solve a few questions. I'm going to reopen this, and the next question, even though it may be possible to solve that question using a positive remainder, I want you to focus on applying a negative remainder to it. Let's get 90 people to say still solving. 3, 2, and 1. Let me remove broadcast results. Here is the question. All right, almost 80% of you are done, guys. Let's get those answers in. Five, 4, 3, 2, and 1. Let me end the poll and broadcast the results. So we got 160 people to put in their answers, more or less, and what you can really see is that choices C and D are really popular over here, and let's kind of get to it. Now, how many of you use the concept of negative remainders to solve this question? How many of you did that? How many of you use that concept? So type in yes if you use that concept. Okay, many of you did. Few of you did not. Okay, use the first method. Perfect. So let's kind of see. So positive remainders, you guys know it. Let's kind of solve it using negative remainders. So what you see over here, the first thing is you draw inference and say, okay, it's a sum of two numbers, which means the remainder of sum of two numbers is the sum of the remainders. So you kind of really say, hey, you express it in this form, it's a sum of the remainders, and you kind of figure out, hey, 24 is divisible by 3, so the remainder for this particular number is 0. Okay, so this doesn't add anything to the remainder, so we have to figure out what's the remainder of 17 to the power 7 divided by 3. Now, the way I would prefer to express it is 18 minus 1. Although you could do it as 15 plus 2 as well, but again, there the math does start to become a bit more challenging. So, so when you do 18 minus 1, or 3 times 6 minus 1, the remainder is minus 1 to the power 7, which becomes a negative number. So you add the divisor back to it by converting it into a positive remainder, and you get the answer as 2, which is choice D, which is what about half the class chose over here. Now, with negative remainders, how difficult was this question? Or even with positive remainders, the question that seemed really daunting, how difficult does this feel right now? It's simple, right? Not much difficult. It becomes a lot easier. And that's the value of not doing the math, but processing what's given to you. Okay. Had you looked at it initially, you would have felt, man, this is very challenging, but now it starts to become easy. All right. So let's now solve another question. Let's get to still solving. Muskan says, why do we add a positive number when the remainder is negative? Because the remainder can never be negative. That's kind of the property that's the basic property of remainders. Let's get to still solving before I show the next question. I'm gonna get 90 people to still solving. And so Muskan, we convert the negative remainder to a positive remainder by adding the divisor to it. So I want 90 people to say still solving before we get to the next question. 3, 2, and 1. Cool. Here is the next question. Again, negative remainder is going to be critical while all right, most of you are done. Let's get those answers in. 3, 2, and 1. Let me end the poll. Let me broadcast the results. It's a 700 level question, which pretty much everyone got right. That's really good. And some of you are saying, hey, this starts to become really simple now. And that's what GMAT Quant's about. So again, same principle. Remainder of sum of two numbers is a sum of remainders. We really say here that over here we're dividing this by 6. So positive remainder becomes a bit more challenging. So we say, okay, 17 to the power 7 by 6. There are two ways you can do it. The first way is you express 17 as 18 minus 1. The second is you express 17 as 12 plus 5. But if you do that, 5 to the power 7 again becomes really difficult. You don't want to do that. So what you do is you express this as 18 minus 1. You get the remainder as minus 1 to the power 7. Again, that's a negative remainder. You add 6 back to it. You get the answer as 5. Pranjal says, what if the power were 8 instead of 7? What do you think would have been the answer if the power were 8? Instead of an odd power, if this were an even power? Yes, the answer would have been plus 1. Yes, absolutely. Yes. The answer would have been plus 1. Absolutely. Now, since you do this, you guys are now primed to solve the difficult questions that we sent your way. So we are now going to go back to the data sufficiency questions, the same 3 questions that we started this particular session with. So I'm going to first show you how you polled. This is how you polled when you solve these questions for the first time. I'm going to now clear your answers, and I want you to now approach these questions using the concept of positive and negative remainders. So I want you to say still solving. Okay. I want 90 of you to say still solving before I show the data sufficiency question. 3, 2, and 1. Okay, I got about 80 of you. I will take that. Let me move the poll up here. All right. Move broadcast results. Here is the first question. All right, 80% are done. 3, 2, and 1. Let's get those answers in, guys. And I see 180 people in the webinar. I only see how many responses? I'm actually seeing a significant number of responses come in. So let me take my words back. But overall, let me end the poll. I'm going to broadcast the results, and what I see is about 50% more people get into the right answer, which is choice A, than did when we originally gave this question. So let's kind of go about solving this question. The question asks, what's the remainder when a positive integer p is divided by a positive integer m, where m is greater than 1? All right. And again, there's not a whole lot given to us. That's all that's given to us. Let's go about doing this. And let's analyze the question statement. The question statement says we have to find the remainder when p is divided by m, where m is greater than 1. So let's analyze statement 1. Okay, statement 1 says p is equal to m plus 1 to the power 8. So we have to figure out the remainder when we divide p by m. So we really say, hey, p by m, this means is equal to m plus 1 to the power 8 divided by m. We have to find the remainder of that, which means we actually take m inside. Remember, we did such questions before, which means m by m doesn't leave any remainder, which means the remainder is 1 to the power 8. Since it's a positive remainder, or well, it's positive anyhow, we'll not use the word concept of negative remainders, we get the remainder as 1, which is a definitive value, which means statement 1 is sufficient. Okay. Now, the nice thing about this is, if you remember positive remainders, you'd say, hey, this guy expresses my dividend in the form of divisor. Statement 1 does that job for me overall. So we know statement 1 is sufficient. So the choices could be either choice A or choice D over there. Now let's go to statement 2. Statement 2 says m is equal to 8. Now what does it mean? Does it tell me anything about essentially p. No, it doesn't tell me anything about p. P could be any value, and hence we don't know what's the remainder when m divides p overall. So statement 2 is not sufficient, and hence we get the correct answer as choice A. Now, for those of you who made a mistake, where did you make a mistake? I mean, given all the questions that we did, I still see 65 of you chose choice C. Why did you choose choice C? For those 65 of you who chose choice C, where did you make a mistake? Okay, you got 1 by m, so the remainder is 1 because m is greater than 1. Remember, that's given to us. Again, that's what we did. For those of you who said didn't realize the remainder would be 1, Akshay, isn't that what we did in product of two numbers? Yes, 1 by m, 1 is the remainder. That's something that you didn't realize. But now can you really see where you made a mistake? Can you see if you were to solve a similar question again, you would not make this mistake? Do not use brute force. Please do not use brute force. That's not the purpose of this. Can divisor be equal to the remainder? No, if the divisor is equal to the remainder, then the remainder is 0. What's the remainder of 6 divided by 6? 0. Bindu says, can you explain why the remainder of 1 by m is 1? Okay, I can, Bindu. Let's do that. What is the remainder of 1 divided by 2 or 1 divided by 3? What is the remainder of 1 by 3? We make this bigger. What's the remainder of 1 by 3? 1. Yes, so where 3 is m, what's the remainder of 1 by 10? What's the remainder of 1 by 10? It's 1. Again, guys, the remainder of 1 by 10 is 1 again. What's the remainder of 1 divided by 100? It's 1 again. And what's given to us? You get what's given to us? We're given m is greater than 1, which means you're not going to have a situation which is 1 by 1. Okay, you're always going to have 1 by 2, 1 by 3, 1 by 4, 1 by 100, 1 by infinity, if possible, or I mean 1 by some other number. Got it? What if 1 is raised to the power 1567? It's still 1. That's the property of 1. The whole concept of 1 is that it's a number which, when multiplied by itself, leads to the same number. That's the uniqueness of 1. Yes, for all values of m, you get 1 as the remainder. Why? Because p is m plus 1. And again, this works. I mean, if you try to get a remainder of 10 to the power 10 divided by 9, where if you think about p is m plus 1, right, which means, if you take m as 9, p is 10. If you take MS as 10, P is 11, and you try and get those remainders, you'll always get 1. Okay, that's the beauty of numbers, by the way, regardless of how big they get. Which admission in R1 am I talking about money? It was R1 for 2020 in general. Yes. If the remainder, yes, thank you. If M is 1, Vishal, then yes, the remainder 1 by M is 0. But again, M can't be 1, which is where it's given to us in the constraint that M is greater than 1, which is why it's given to us, so that you can get to a definitive answer. If this were not given to you, then you couldn't have gotten to a definitive answer. Okay, that's why it's given to you, so that choice A can help you get to a definitive answer. Now, I love when people are speculating, where people are saying, hey, what would be the solution if instead of P is equal to M plus 1, P were M plus 3? In that case, most likely, yes, the answer would have been E. Absolutely. Or we'll have to then process statement 2 to really say what does it lead to. So because it's statement 2 where M is 8, we probably could have gotten an answer. Then it could have been E. Okay. If instead of M plus 1, this were M plus 3, then you would have known, you would have had to know what is the value of M, and you would have had to combine both those, and you would have gotten an answer. Yes. Then the answer would not have been E, it probably would have been C. So, but again, that's not what the question is. Remember, GMAT quant is not about you doing the math. All right, let's get to question number 9. We're going to do that. But again, you can see these questions start to become fairly simple once you do this. So question 9, this is how you polled. Okay, and you can really see there is no definitive answer. Now, let's reopen the poll. I want you to select still solving. Five, 4, 3, 2, and 1. Come on, guys, let's get to still solving. This is probably the last question we'll solve because we've taken quite a bit of our time. And then we'll go towards the end and I'm going to give you the PDF so that you can see the solution for question 10. All right, here's question number 9. Good luck. All right, 80% of you are done. Let's get this going. 3, 2, and 1. Let me end the poll and broadcast the results. So this is how you guys did. I mean, so you still have a split jury here, but I think many more. I think about 20 to 30% more have chosen the correct answer. Now, this particular question requires that you choose another process skill, which we call as consider all cases. So how many of you, by the way, are feeling good about this webinar to really say, hey, this starts to make things simple? How many of you are feeling good about this? Okay. All right. So the reason why you start to feel good about this is because in this webinar we've talked about we're not doing the math, but we are focusing on something called as process skills. And there are 6 process skills that you need to master to ace anything in GMAT Quant. And so we've actually outlined those process skills in on our YouTube channel. So for those of you, for each one of you to access. So one thing that I'm going to do is I'm going to share the link to our YouTube channel, and we will continue to showcase examples to process skills. So in the Q&A pod, you should be seeing something pop up over there with process skills. So if you want to really understand what those process skills are, just subscribe to the YouTube channel so that you guys can go through those. There are about 25 short videos, 5 minutes each, that are over there. And once you go through them, you find that a lot of GMAT Quant becomes very simple. Yes, if you want a question bank to practice on this particular topic, if you're an e-GMAT student in Scholaranium, and in the e-GMAT course, you have about 80 questions just on remainders or so. Okay, so with that, let's get to this question. So I just want to make sure that you're aware of that resource. The YouTube channel with the 25 odd videos is there for you, and you'd see Pyle, outlining how to use these process skills over there. So with that, let's solve this question. And again, this is the last question that we'll solve, and then we'll tell you what to do next. So the thing which is there in this question is what's given to us is that n is a positive integer, and the question asks us, what's the remainder when 38 to the power n square is divided by 13? Okay, so when you look at this term 38 to the power n square and you say 13, and you say, man, 38 is so close to 39, and 39 is divisible by 13, so this must be negative remainders. How many of you really said, okay, you saw 38, you saw 13, and you said, I've got to apply negative remainders somewhere over here? How many of you figured that out? Okay. All right, 80% of you were able to figure this out. And that's something which is what we call as simplifying, and I'm going to show how to simplify this. So Muskan's asking, what are these process skills for? These process skills are the key skills which you need to master to be able to do well in quant problems, and simplification is one such skill, which is what we are using over here. Now, when you think about stuff, right? When you make a mistake in a quant question, you say, okay, I made a mistake because I didn't know this, or I made a careless mistake, and then that kind of mental or even actual error log tagging is often insufficient, in the sense that it doesn't help you improve as you solve more and more questions. So when you tag questions with regards to process skills, it does two things. It makes your tagging more specific, A, and B, it tells you why and where you're making a mistake. For example, over here, if you did not do this simplification, you can tell yourself, hey, I'm not simplifying the question statement that's given to me. And if you start to see that happen more and more often, you can really see this is something that you need to work on, and you can be very certain if you work on it, your hit rate's going to go up. Okay. So then let's kind of do the question statement analysis over here. So what's given to us is we're given that 38 to the power n squared divided by 13. We need to find the remainder of this. So let's analyze this question statement over here. So what we do is we express 38 as 39 minus 1. Again, we could have done 38 as 26 plus 12, but we don't want to do that. The negative remainder part remains much easier, which means because 13 times 3 or 39 is divisible by 13, our remainder is minus 1 to the power n square. Now there are two possibilities that exist. One is if n is odd, then my remainder, and the second case is n is even. So if n is odd, then my remainder is minus 1 plus 13, which is 12. If n is even, then my remainder is again plus 1y, because I don't get a negative remainder, I get a positive remainder over here. So overall, essentially, I only have to figure out when I look at statement 1 or n2 whether n is even or n is odd. How many of you were able to get to this level of simplification? How many of you were able to get to this level of simplification even before you look at statement 1 and statement 2? Be very honest. This is the pre-processing we need to do even before you look at statement 1 and or statement 2. How many of you were able to get to it? All right, but 68% of you did this kind of processing, and I only have about 90 people who've responded to this poll. So, all right, and again, if n is odd, an odd square is odd. So overall, square of an odd number, which is where if you go through our even odd module, you'll really get that. So 3 square is 9, 5 square is 25. So if n is odd, then it's going to be a negative remainder. Then you make it positive. If n is even, which is 2 square, 4 square, 6 square, then the remainder is positive. All right. So let's kind of look at this over here. So the only thing that we need to figure out from statement 1 and statement 2 is, can we say with 100% certainty whether n is odd or n is even? So let's analyze statement 1. Statement 1 says n leaves no remainder when divided by 4, which means n is equal to 4k plus 0, because the remainder is 0, which means n is even, which means we can be very certain and the remainder is plus 1, and statement 1 is sufficient. So our only options remain either choice A or choice D, where either statement could be sufficient. Statement 2 says, hey, square root of n is divisible by 1 and itself, which means that square root of n is a prime number. All right, which means n becomes a square of a prime number. Okay, when n becomes a square of a prime number, then essentially, which it could mean that n could be either 2 square or 3 square or 5 square or 7 square or one of these, which means your n could be either even or it could be odd. All right. So because n could be either even or odd, we can't say for certain whether my remainder is plus 12 or my remainder is plus 1. So statement 2 by itself is not sufficient, which means my correct answer is choice A. N cannot be also 1 because square root of n is divisible by 1 and itself, which means there are two numbers, Dhruv. Okay, for statement 2. It's a good question that you're asking. Does that help, Dhruv? So n can't be 1. All right. Priyanka, even odd module, I think, is a part of the paid course. So, yes. So, can I explain the two cases? Yes, the cases are a classic case of negative remainders. What we've done is we have said, hey, we have to find the remainder of 38 by 13, and which means I can express 38 as 13 times 3 minus 1, and the remainder of this is minus 1 to the power n square. Now, if it's minus 1 to the power to a certain raised to a certain power. If that power is odd, I get the negative remainder, which means I have to convert it to a positive remainder as we've taught to you, and which means it's minus 1 plus 13, which is 12. If n is even, I get a positive remainder, and my remainder is plus 1. Those are the two cases, Shubham. All right. So with that, let's understand where do you go from here. I'm going to leave question 10 with you. I'm going to share the PDF overall. But the thing that I want to make sure that you take away from this is, you can master a GMAT quant. I mean, this is, many of you started from really the very basics, and you were able to solve some very challenging questions. And the reason why you were able to solve these challenging questions was because we focused on inculcating good habits, and we focus on mastering them overall. So if you continue to do that, you can go from a score of, let's say, a Q35 to a Q50, and so on and so forth. And I'm going to show some people who've done this right now. So Krish, for example, was someone who was really good at quant, but he was unable to go beyond a Q48. Why? Because he was just blindly solving questions. He wasn't tagging why he was making mistakes. He was doing the math rather than focusing on the logic aspect of it. All right, and which is where he was stuck at a Q48, despite being someone who's really good at quant when it comes to how he did in his school. And one of the big problems for him was data sufficiency over here. He said, since I was good at math, whenever I see a DS question, I start solving it. And a lot of us have that urge of doing that because that's how we've been solving math. I don't want you to do it. Okay, and once he started not solving it, once he started using the right approach, what he was able to improve to a Q50 when he actually scored a Q51 on the real test. Okay. As another guy who improved from Q45 to Q49, Leo actually is graduating from Wharton right now. You can watch his video debrief over here. And this guy was stuck at a Q45 despite working really hard. He actually scored a V44 as well, which is 98 percentile on verbal. So what helped him improve to a Q49? One is, again, stop doing the math, started focusing on the logic. The second is figured out where he needed to focus on the logic, because there were certain areas where he did really well. There are certain other areas where he faltered quite a bit. And so for him, defining those areas was really important. And then he practiced using Quant Scholaranium once he isolated those areas. He's secured admits from Stern, Tepper, and Wharton. And again, as I said, he's graduating from Wharton. There's another guy who went from a Q30, which is the 20th percentile, to a Q45. Again, for him, the key was not to solve difficult questions. He started from the very basics. Why? Because, again, if you don't have the basics and you start to solve difficult questions, it's like trying to run before you can learn how to walk. And so once he realized that he had to start from the very basics, and he started from there, he was able to go from a Q30 to a Q45. Again, it's about doing the right kind of questions, understanding what stage of learning you are in, doing the right kind of questions accordingly, and going from there. And as a guy who improved from a Q38 to a Q50, he's actually studying at Wharton as well. And again, his dream school was Wharton, and the score of Q38 Wharton was like a distant dream for him, because Wharton requires that he get to a Q47 or higher. So what helped him improve to a Q50 overall, the simple focus on rather than practicing, he focused on learning. And as he focused on learning, he made sure that he focused on one area at a time, increase his ability in that area. So he focused on number properties first, algebra next, word problems, geometry, and then PMC probability. And then in each of these areas, he tracked his improvement every 30 to 40 minutes overall. So again, to ace a GMAT quant, the goal needs to be that don't solve a ton of questions, focus on learning and adopting these good habits. Okay. Towards the end, and these are things we've all talked about. One thing I want to emphasize on over here is that hey, don't start getting into solving the question right away. Become an active reader, process that question statement that's given to you. And the second thing is trust the test maker. You're not going to get something which requires a ton of math. Even if it seems complex, if you spend time on the question statement without worrying about the math, you're going to be able to simplify it as we were able to do this in this particular webinar. And then the last thing, trust in yourself. I mean, this is something that you can do. You have everything in your arsenal to get there. Okay. With that, I want to end this webinar, and I want to thank you guys for joining me today. I'd appreciate some feedback on the webinar over here. That'd be really helpful. And then let me share the PDF with you as well. Okay. So again, go take a look at process skills and essentially subscribe to the YouTube channel. Discount to the course. We are offering some discounts. Again, I don't have anyone from my sales team who can tell us what those discounts are. But since this is the beginning of the month, you can write to rajat at e-gmat.com. And we can help you with those. Did we solve question 3? We did not, but you can download the session PDF. It has the solution to question 3. Again, now the discounts limited for today only. Forgive me, guys. I mean, I am not the one who does sales, so I can't really tell you. But it should be. I know they usually go till the first of the month or so, so they probably will be available till tomorrow. But I mean, forgive me for that. I don't have anyone from my sales team to do this. So, but again, if you write to rajat at e-gmat.com, someone from our sales or support team will help you get the answer. Okay. Now, some of the other webinars that we have next week, we have an RC webinar. Let me actually share this over here. So upcoming webinars, we have one by a Kellogg admit. This one's tomorrow, which is, hey, how did he get into Kellogg? And then what's the impact of COVID and how has that impacted his decision making? And then next week we have an RC webinar and a quant workshop. If you've attended the quant workshop, it probably will have the same questions before overall. Are there any specific webinars for users who've subscribed to the course? No, not yet. We don't have any paid webinars as of yet, but yes, we are planning some. In the next webinar, we'll be taking reading comprehension. For quant, it's going to be like a quant mini mock, so you'll have questions from all topics, but we won't be solving those questions. We'll be analyzing your responses and giving you feedback. Will the online test continue beyond 15th of June? Yes, it's going to continue till 15th of July at least. That's what we've been told by the GMAT. And you should be able to get dates till 15th of July. If you're not able to do so, please write to me because I've been assured by the GMAT that it's going to continue. Can you get the recordings of previous webinar? They are on our YouTube channel. Let me share the link to our YouTube channel. Hold on. So here are the recordings of previous webinars. What will be the impact of AWA as it is not in the online? There's no impact. I mean, very few B schools even worry about AWA, and fewer still add any weight to it. So yeah, there's going to be zero impact of AWA. So yeah, don't worry about AWA. And if you want to really see how people have done this, I mean, essentially we've had many students who've done really well. So let me share some links over here. There's a link to a student who scored 730. If you go in the same playlist, you should be able to get a few more videos of people who've taken the online GMAT overall. Upcoming webinar links. If you log into the e-GMAT account, you should be able to see them in the right-hand pane, guys. But yes, if you write to us, I can also send those to you. Again, my email address is rajat@e-gmat.com. It should come up in the Q&A pod. All right. Okay, guys, with that, I want to thank everyone. Okay, I have this question. Is online GMAT not a permanent option by the GMAC? Is it, and it's only for the interim period? That's what their position is so far. And again, depending on the popularity of this medium, they might make it a permanent option. But right now, what we know of is that this is something which is an interim solution. But I think it's a great solution for people who have a quiet space in their house. All right. So with that, I want to thank everyone for joining me today. It was wonderful having you guys here. And I look forward to seeing you on e-GMAT.com. Thank you and have a good evening.